Hi everyone, this is Physics 2211, Lab 5, where I'll be looking at the ballistic pendulum. So basically, if you don't know what a ballistic pendulum is, we have a pendulum that is then hit with a projectile moving at high speeds, and using this kind of method, we can find the max angle of the projectile and pendulum as they stick together, and then also we can find the velocity at impact of the projectile based on the momentum principle, because this is a perfectly inelastic collision. So the main physics principles are the momentum principle and then variations of it. So when we are looking at specifically the pendulum, you have to include your sine and cosine as the pendulum moves. The result of this was a model of the demo, and the model can predict the max angle, and the max angle was found to be 52.97 degrees. Energy was only lost through the surroundings. The system is the bullet and the pendulum, and then the surrounding is air. So initial conditions, the length of the rod is 0.33 meters. The mass of the projectile is 0.0086 kilograms. The weight of the pendulum bob is 1.6 kilograms. Theta, the initial angle, is 0 degrees. And then the initial position of the projectile was the vector negative 0.20400 meters. So then the data was found on YouTube and then was put into Tracker. So as you can see, the axis was set up there, and then the calibration was based on where the actual rotation, the point of rotation is to the end of the rod, because that was measured to be 0.33. And then after that, the calibration that was set, we used Tracker. However, there is a big point of error here, because as you can probably tell, the video is a little askew. So the width of the actual video was too large for Tracker, and you couldn't actually fit the whole pendulum movement into it. But I'll get more into that later. So then this is the main portion of the code, which just basically updates the alpha, omega, and theta as the pendulum is moving, and this allows us to not only calculate the x movement, the y movement, but also the changes in potential and kinetic energy over time. And then this is the results from Tracker. As you can see, the y-axis or the y values are a little bit messed up. The x values are luckily very well done, just because of the fact that the x values weren't as hard to keep in frame. The y values, however, were very difficult to keep in frame. Then this is the results from the code, much prettier. As you can see, our x and our x value here are very, very similar. Y is where it starts to look a little weird. However, if you do take into consideration the problems with Tracker, it does look pretty accurate. And then finally, this is our time graph, or our energy and time graph, sorry. And then our findings, the max recorded angle was 52 degrees in Tracker, and then our max recorded angle was 52.97 degrees instead in the model. And then sources of error, as mentioned, Tracker was very difficult to work with here. The video format didn't allow some of the frames to be tracked, and then the width of the video is too wide. And then other sources of error is also human error, just due to calibration, and then this could cause improper ruler measurements and angle measurements as well. And then what if? So the what if question that I'll be answering is, what if the mass of the projectile was greater? What would happen to the maximum angle? The max angle would increase since momentum is equal to mass times velocity. A greater mass would increase the momentum if fired. At the same time, it would increase velocity. I'm sorry for my error there. And then what does this mean? This example is a simulation used to explain perfectly inelastic collisions. How can this be applied even outside of the pendulum model? So this looks like two masses sticking together after a collision. So this includes car crashes and clay hitting a wall. This can be used to explain the change in velocity that occurs as masses collide and stick together. So yes, thank you so much for watching, and I hope you enjoyed.